Hello? Hey guys. Hi. So, just wanna, okay, that's fine. So yeah, this is being recorded, just so you know. Why are you all here if it's being recorded?
I just want to hear some gems, because you might have forgot to tell us something and put it in the exam. So.
How dare you insult my competence? Okay, gems. Man, I wish I was more excited. So the only real thing to go through today is to just do another quick explanation of the exam and how to interact with it. Besides that, it's just like a general Q&A. So there's nothing specific. So just as I've mentioned before to people, if you came here to hear something specific, pretty much everything was said on when I last saw you. And otherwise we're just like general mishmash. So I guess just the environment's in a place now where we're like happy with it. The general gist is when you get to your lab on Thursday, as we talked, this first bit we talked about before, you'll be prompted with a screen like this. That is not my password. I guess you know how many letters are in my password now. This is what you'll get prompted with for your exam. Now there's three really important parts to pay attention to. One is that you have a multiple choice section of your exam. One is that you have a short answer section of your exam. The other one is that you have a CPP reference document in the background opened up in a web browser. This CPP reference is the one available on the Web CMS 3. You can go and click on stuff and read stuff. Again, I would recommend, if you haven't, one of the most valuable study tips is not to go and revise particular content, but get very comfortable with the reference document. Because there's probably, I don't know, depends on your knowledge, but let's say for the average student, there's maybe 10 to 20% of questions that like are pretty straightforward if you know the answer to something in the CPP reference file page. So it's just go look it up. So just get kind of comfortable with the basics. I don't mean hours. I mean, maybe spend some time, and probably what I would do if I were you to study is I'd be like, you know what, I'm just going to write down a list of 10 things I might want to know. Decal type, standard vector, standard accumulate the algorithm. And I'm just going to go find it and just play around with it till you find it. So that's CPP reference. Now, in these exam environments, you just notice that I closed the web browser. You're probably likely to do that. If you right-click on the desktop, you'll see the three things you care about the most are sitting up here, including your two exam papers and your cppreference.com. And if you click that, you'll get it back up. So you can close that, reopen it, do anything you want. Now, again, the important thing is that for the first hour of your exam, you're not allowed to use a terminal. We give you one to start just so that you're not confused how to open it. But yeah, so pretty much for your first hour, all you do is you just sit here and you use this screen and your CPP reference screen, and you get a whole bunch of questions that look like this. Question, tick a box, go tick a box. These are not questions for C++. You click save, it saves your work. At the end of the first hour, you'll be asked to close it. So you click quit, you click yes, and now you can go and do any kind of coding you want for the rest of the exam. And only work in this part of the document, this part of the exam, which is where you do all of your short answer and coding questions. And again, just to recap so you know, let's say I want to work on this question here. It's asked me to make some modifications to a file. So I'll open up that file. I will add some modifications to it. I'm tired. I will modify the file. That's how you close the entire VNC viewer. That's not how to do your exam. Sorry about that. Yep, so I had my file, I modified my file, didn't work. And then when I'm done, I just follow the instructions. I can test it by compiling it with the line that's given to me on command line here. And I can run it, question 27. And then if I want to submit it, I submit it just like it says, give 27, question 27.cpp. We talked about this last time. That's pretty much it. Your coding questions will involve writing code and submitting it like that. That's how you submit stuff. If you're not sure, just type in the command again. And the short answers will get saved, just like the other stuff. You don't need to do anything here. You just click the save button up the top. Yeah, that's it really. Yes?
How good or fast or slow is VS Code? Yeah.
Oh, that's a good question. I have no idea. So it's a great question. Vim works. There's a Vim RC that should be in here. Yep, there's a Vim RC that should be in here. This is the stuff that's been added to it. You can go look at it. If you have any religious disagreements, please let me know. There's also another Vim RC which is taken from Google. I don't mean the company, I mean the website. That has a whole bunch of other stuff in it, which a student asked for this, so we've just put it in here. Gedit, obviously. There was also the Dean, I think.
Yeah.
I never used Tmux before. It's confused me at the start. It's just like another shell, but I assume it's like a shell with powers now.
It's pretty cool, right?
Yeah, I'll have to learn it. VS Code. You type in VS Code. Oh, what the hell? That work code? Oh, you have to type code for VS Code. This will be in the instructions. I don't really use VS Code, so let me see how easy this is. Open file. Great. Well, that was easy. I don't really know if you would. How would you normally just run a standalone file?
It has a term.
Oh, cool. Sweet. Yeah, well, that's it. So yeah, you can pull it all up like that. I mean, it seems fast enough. This is me remote desktoping into this VLab, right? So the actual CSE machine should be as quick, unless you're in a particular lab, which is a bit slower, I guess. Lie is pretty slow. Yeah. That's it. I just wanted everyone just to see it. So remember, you have 2 exam papers, so don't be alarmed when you open your exam and you're like, where is it all? It's just hiding at the back. There's 2 of them. That's just so you can close one. One thing that I'll also keep reminding people, you can work on section 2 and 3 in the first hour. Okay? You just can't use a terminal for it in the first hour, right? So if you finish all your multiple choice and you're really bored, you can go and start answering questions from 2 and 3. There's some in here you can definitely do without a terminal, because some of them are just theory questions asking you, like, define this or whatever. So you're welcome to. This 3 hours, anytime, you just can't use a terminal. Yes?
Does using Vim count as using the terminal?
Yes. So pretty much, that's a good question. We'll be super, super specific. There are like 3 things you can use in the first hour. One is your exam paper itself. The other one is CPP reference. And the third one, I believe, is calculator. You do not need this. Okay? You do not need the calculator for anything. If you do, you're probably doing something bad. So yeah, first hour is just the website and the exam paper. That's it. Cool. There was also a student who asked if we can release some Section 3 practice questions. Yes. The reason we haven't is because that's the last part of the... We've like completely finalized, locked in Section 1 and 2 of the exam. Section 3, we're just like deciding on some last questions. So again, we're just like releasing the ones that we aren't going to ask you. That exact question, it doesn't mean we won't ask you something on the topic. Scat. Fooled. Yes, question?
Can you update the CPP reference on the course website to be identical to what you just shown? Because there's a lot of coding issues on the one on the web CMS one. It's got a lot of weird A's.
Yeah, I saw the weird A's.
Have you, can you update that so we can just practice using this reference?
Yeah, that should be fine. I will get to it ASAP. I'm currently on trying to sort out assignments and other things at the moment. I understand it's frustrating. In the meantime, just close your eyes, I guess. Yeah, well, I'm not sure what happened there, given that like the CPP reference used in the exam environment was literally just SCP'd from this one. So,
Is it a Windows versus?
I have no idea. It's pretty weird because actually, like in the source code from memory, I had a quick look at it on my way here. It's like it's just chilling here. I'm not sure what the hell that means. Okay. Question time. If you have anything. Otherwise, we can just go home and have a reflect on this awkward experience.
Any like must-know topics, or else we're basically up the creek to the pedal?
I definitely still focus a lot on polymorphism stuff, both because it's 10% of the weeks of teaching, but it's more than 10% of the exam. Like not by a huge factor, it's not like a quarter of the exam, but it's disproportionately large for the topic size, very slightly, and it's also harder. And again, we haven't done many assignments and stuff on it. So I'd say polymorphism's definitely up there as something to really get your head around. Everything else is just kind of like little drips and drabs of topics. Like,
There's so many little drips and drabs of topics everywhere. You just like overwhelmed when you run through it all again.
I'd say that there's around like put it this way, I'd say like 5 to maybe like 10% of the exam is what I would call footnote questions, as in questions that test whether you actually were really listening in like the lectures and stuff,
No.
as opposed to just like, I get all the key high level stuff, sweet, moving on. So like a lot of the exam you'd be fine in just like understanding the content. It's not like we're gonna like be nitpicky and be like, ha, you missed that edge case that we didn't talk about. You know, like object slicing occurs when we cast subtypes, except in cases where the subtype contains an integer or something random ass like that. We're not gonna, that's not true by the way, guys. Just in case. But yeah, nothing really obscure. It's actually an easy course to examine because we taught a lot of stuff. So we can just like ask lots of questions. Yeah. Yep.
For the reference collapsing, when do you have like L value reference to R values? Like when do they appear?
When you mean like when does?
Like the reference collapsing is when you have like a L value reference to an R value reference. Like in the template type ref, if the type gets reduced, it's like an L value, then you have like an R value reference to an L value. Is that correct? Yeah, like when does,
I guess it's like, I mean, if we have say we have a function, tell me if this doesn't answer your question. You know, and say we have something like this, right? And this might be to cover reference collapsing for the broader group. The thing is that, and just so everyone's clear, reference collapsing basically says that when you pass in, we talk about like a non-const R value reference type within a templated function allows anything to bind to it. That doesn't mean that anything that's passed into it is just by default an R value reference, because what's actually happens is we pass in B, and B is of type L value reference, but that means that the type T here, that is an int reference, like an L value reference. So the actual type it tries to resolve this to is int reference, R value reference, and reference collapsing will use like these rules, there's only 4 of them, to say that it becomes that. So the actual type inside the function will be an L value reference.
Well, when does like case 3 appear?
When does case 3 appear? Probably in the case where you have something like passing in standard move of A, and your actual function here is, say, like a non-templated a reference to constant, like that, where you're passing in an R value reference.
It becomes an L value.
Yeah, exactly. Like a const L value. But yeah, the actual type here, I think, that could be a different case, sorry. I think reference collapsing to do with templates. Let me go away and think about that one, just so I give you like a proper answer.
Like the type will get deduced as like the R value, right? Or like case 3. Like if you have like the A ampersand, the type would get deduced as like an R value, right? But then you have like another ampersand somewhere else in the function header.
I don't fully understand what you're asking, sorry.
Like I don't really know what I'm asking either. But
That's okay.
I guess, yeah, like I'm just not sure where that appears, I guess. Like it makes sense for the R values.
Yep.
And I guess like if it's just outside of template stuff, then I guess it's fine as well. Like in that example you had, it doesn't really work.
I think there was a good there's a good question that came up, and I think it's in week 9. Or it's in the lecture notes. I can't remember exactly where it is. Yeah, it's here. Again, it's not exactly the same case, but I remember a student. I know I'm probably not answering your question. This was another case where someone was confused why.
Like I mean in that question, A will be like an R value or an L value, but you'll still have like the 2 ampersands, like it'll still be an R reference to like an L value reference or like an R value reference, right? Like it would still be case 2 or 4 on that previous, on the like reference collapsing table.
Oh, sure. Case 2 or case 4.
Because you always have like depends what T gets deduced as, right? It's like
Yes, I think it's a good question. I again, like, I'll go and have a think about it and give you a better answer. Yes.
Could you just walk us through that exact example? I mean, just literally the one we just had.
This one here?
With this, yeah, it's good standard forward stuff. Even just the first function, like how does that reduce to 1, F1 to 3?
Yeah, so how does this deduce to
Just in the first line.
this one?
Yeah. I guess they'll print out a 1, but just how does that actually work?
So, I mean, in this case, what happens is that we pass in just 3 integers as arguments here. And then inside this function, these 3 integers have type int R value reference. So lowercase a, lowercase b, and lowercase c are all R value references of an int. This is where standard forward's not really necessary, because this would happen anyway without standard forward. Standard forward more helps in some of these latter cases. But in this case, what then happens is like E is being called with 3 R value references, except that we can't bind an R value reference to a non-const L value reference, but we can bind an R value reference to a reference to const int. So R value references can bind to this, cannot bind to that. Therefore, the compiler is able to determine that this is the overload that's appropriate. Yes.
What if it can bind to both functions?
I don't know. Let's try it out, friend.
Does it just choose the first one that's higher up?
there's like overload thing rules on there for like what's the best function to pick.
Yeah. If it's ambiguous as to what the best function is, then
Can you compile complaints?
sorry.
To compile complaints, I think. Like if it can't find the most best fit.
Yeah, I would guess so. Oh god. Did I just save that? Anyway. Let's see. What's in here? Might make another folder in here. Okay, so just sanity check this works. Okay, let's try, I don't know, let's template the thing maybe. I'm just making this up. Yes, sure. I guess an R value reference is closer to it. The problem is like, what else binds to it? I guess an R value reference itself, right?
Wait, isn't it an R value reference though? Like just the numeric one?
This one?
Yeah. Like wouldn't that always prefer an R value reference over
Yeah, I guess it would, and I don't think it can bind to anything else except. Do const R value references even make any sense? Yeah, I guess so. Like, I guess it prefers an R value reference. Otherwise, it'll find a const R value reference, and if not, then it can bind to it.
if you have like the R value and the const R value?
Oh, you mean like in the same one,
Yeah.
like this?
Yeah.
Yeah, it's probably gonna go to the non-const. Oh.
Oh, the other one's complaining, like the other functions.
Oh, sure. It'll probably go to the non-const one. That's just like how non-const member functions will prefer, non-const objects will prefer non-const member functions over const member functions.
But does it make sense to have like a const or an R value?
I don't know. I genuinely haven't, like a lot of the things in the course, there's just particular use cases I haven't plugged together myself. But no, I'm not sure what the implication of having a const R value is, because I understand what you're saying. Like an R value inherently is not an address or an entity that you can like change. It's just a thing. So I'm not really sure if there's any scope to change R values.
Can you explain the second one after this?
This one down here,
Yeah.
sure.
Like, because it should be able to,
What was the code?
like, both functions should be okay, right?
Yes.
But why does it choose the bottom one? Two.
Wait, why isn't const a variable?
Fuck. Are you asking why it prints out 2?
Yeah. Because I think the first one is also okay.
Like the inline isn't const?
Yeah,
Even
so
if it's not const, like, shouldn't the first one still be okay? Because it's not
like
const?
it could still be a candidate, right?
Yeah.
Because you can, like a non-const item can bind to a const parameter.
Yeah.
So it's like a candidate. It's just like as all overloading rules, like you get a set of candidates and then you narrow them down. And I think this was covered very briefly in the first week in not much detail, but like the third step is, it's like I think there's 3 steps, and the first step's like finding all the same name, and then the second type's ruling out ones that types don't match. So if this was like a const double or something, actually that might still work, but like a const string. And then the third step's actually being like what one like fits the best. And in this case, it's going to prefer something that's more literally the type instead of something it has to bind to a const version of it.
Okay.
Yes,
A couple of questions, if you don't mind.
that's okay.
If anyone's has a complete NAD in, say, the third assignment and fails, gets less than 50% of the assignments,
Can they still make up for in the exam, or are they stuck?
Yep.
Okay.
Yeah, we talked early on with a couple of students about whether to do like a harmonic mean or some kind of equivalent for marking. But yeah, we're fine with people getting, someone could get, I guess, 100% in the exam and not have submitted any assignments and pass the course.
Okay.
The general idea why that's the case is because, again, exams are the one time we feel we can genuinely assess students, whereas assignments like aren't. So it wouldn't make sense to, that's why a hurdle exists, because otherwise you could say that a student could cheat and then get a huge assessment mark, tank the exam because they know nothing, and then still pass, which we want to avoid. So yeah, your assessment marks can definitely be offset by your exam marks.
Okay.
Yep.
Just one other question, please. I just want to ask about, you know, exceptions. You know, there's different types of exception. I don't know quite what the word is. Exception safety.
Yes. Yeah.
Can you just go through them again? I'm not quite sure about.
Yeah. Sure thing. That's why we're here. How many people here use password managers? Okay.
iCloud.
Yeah. I don't know whether I get one. Was it exceptions?
Well, if you lose one password, yeah, it's just chances are they're going to be cheaper than your other password.
That's true.
I was wishing my 684 one.
So I guess that, okay, so exception safety levels. The top and bottom one are really easy. Bottom one is just that there's no exception safety. Basically, like, anything can happen. Like an exception could be thrown and the whole program could just crash, or you could memory leak, or like who knows what. It's just saying no guarantees about anything. The top one's the easiest, and that's the no except case. Often functions that are no throw are specified with no except at the end. And that essentially says that no exception will occur, as far as you're concerned. So what can happen in these functions is an exception may occur, and then it will be handled within the function. And that's it. So yeah, as far as you're concerned, no exceptions happen. And these two cases say that exceptions can happen, and they provide different kinds of guarantees. In the top case, what it says is like, there's a bit more detail to it, but the way we've taught it in the course is that you imagine when like you have a class. This is typically talked about in the context of classes or objects. You have an object which has a whole bunch of member fields. So this object has a state. Then you call a function, and typically a common thing functions will do is they'll modify the state, right? What a strong exception safety type or function or whatever does is it says that you may call me and I may start doing stuff, I may start mutating the state, but if anything goes wrong and I throw an exception, I guarantee that I will like roll that back to the point before the exception was called. So it's like I ensure you that there's no side effects. That's what we call it. As nothing changes, the exception's thrown and everything's exactly like it was before the exception's thrown. And then weak exception safety is also, this says like no memory leaks will happen, right? So it's like we'll roll back stuff and we won't leak memory. And then weak exception safety is just saying we won't leak memory. So there may be things that occur and we won't roll back. There may be side effects, but the minimum we will guarantee you is that if we malloc anything, if we knew anything, we will delete it. We'll make sure that that's freed before we get that exception back to you. Does that help?
Yeah, it's good, thanks.
Okay, cool.
So, sorry, just how would you implement, say, a no throw? Would you have to just track everything that could possibly happen?
Yeah, I mean, it depends on the operations you're doing. You know, like if you're just adding an input integer to a member integer, then integer addition has no exceptions that can be thrown, right? It can just overflow, but that's not really an exception. So it really depends on the type of thing you're implementing.
What would you say calling a database or something like that?
Yeah, like if you're calling it a database, then the first thing that can go wrong is that you have a connection error. So it'll be nearly impossible to have any kind of database file network operation that is a no-throw thing, because I mean, you could probably make it no-throw, like you read a database row, but then it can't connect to the database. So you cache the exception, and then instead of bubbling it back up, you just return an empty row. It's like, that's cool. Now it's no-throw, but it's fucking useless, you know? So, yeah, exactly. So it would really depend on the type of what you're actually implementing. That's why things like vectors.at aren't no-throw, because it's pretty much impossible to make like an index lookup of an array no-throw, really. What's up, Dean?
Why is it important that we classify our functions in terms of exception safety levels?
In general, I'd say it's pretty much just about understanding the limitations of a function. I would say that, you know, in my experience, I wouldn't be so much fussed that someone would like know these and like, you know, and say a workplace like points to a function as like, that has weak exception safety, but just that understanding that the way we handle errors sometimes have limitations. Just because it helps you understand, like when you're coding stuff, you need to be aware of it. So I'd say like the specific definitions and words and stuff aren't super critical. That's mainly just for assessment reasons. But the idea of it, I think, is just good to know as a programmer.
So the move constructor is no excepts, because like if something happens, then you can't go back so you won't crash, because you can't, like this, it doesn't make sense to throw the exception higher up. Okay.
Yeah, I believe so. Yes.
I'm looking at the advanced templates with the 8 slides. Can you go to 3.7?
I got a bad feeling about this.
It's not this quiz.
Why can't you guys ask me questions about const? What was it? What was it?
3.7.
This is the only part of the slides that... Did I click on the wrong thing? Did you say advanced templates?
Templates, yeah.
It's because I can't hear you. I'm sorry. No, it's because I'm stupid. This is the one piece of this week's code that... You said 3.7?
Yeah, maybe I've got like the older version.
No, I'm definitely retarded. Don't worry.
Wait, no, not this one.
Not this one. I don't think quiz comes up in the lecture slides anywhere else.
Do I just have like an older version? Is that why?
There's more. Oh, do you have the PDF?
Yeah.
Ugh.
You can do it. Can I show you? Is that something?
If it's not in the PDF anymore, there's a chance it's because it's either wrong or irrelevant.
Ah, how good then?
Like there's 2 quizzes in the video.
Is this not the 2 quizzes?
Yeah.
It's under explicit specialization.
Yes. Yeah, this was there's the one part of just before we gave this lecture, got into a conversation with, I think it was Matt and Nathaniel, about specialization and what it means and all that other philosophy stuff, and we made some 11th hour changes to these slides, including adding the quiz or cutting something out. So I think you're just a victim of that. I'm sorry.
Could you explain the template parameters?
Template.
Slides, yeah, the bottom one, left the bottom one.
Yeah. Can you guys see the screen? Should I just turn the lights off? Can I do it from here? Yeah. Let's keep going. All right. That was anticlimactic. Oh god, this is awful on this screen. So the template parameters, this is definitely a part of the course that is not super commonly used. Like, if you Google it, you'll find fairly little information about it. But you know, the course is called Advanced C++, so we have to teach you some different stuff. I like to put it like this because what we're really saying here is like template parameters is just saying that your template parameter itself is a template. So what you're really saying in this line here is you're saying, if I was to just have this like this, I'm saying that I have a class and it's a templated class across a type T and a type cont. You know, two types like int or double. These are just two types, I'm giving them names. In the case above, what we're saying is that I have a class that's templated across a type T and across a template as well. So it's essentially saying that here you don't expect a type, you expect a templated class. And how that works is that, by the way, these were slides that were updated like yesterday because a student pointed out a bug in it, which was a carryover bug from slides in this course from a few years ago. But like, if we just have a look at, let me just get rid of these things up the top. If we like just compare this, I know this is the wrong way around, the bottom is before and the top is after. You can see that this one, if we want to instantiate this, again, we have to do it by saying, whatever it is, stack int, standard vector int, right? And then the old example is that for this one, for this one, we can just say standard vector, and the reason is that's good for a whole bunch of reasons. It's good because it makes the code simpler. It's good because there's less room for you to write, the wrong code. It's good because technically in some cases you can get situations where that still compiles because, you're not really making a stack of ints. You're making a stack which has a type T in it that's an int and has a container that's of type double. So that could validly compile depending on how you've implemented it. But the thing is that int is a type here, and standard vector of int is a type. That's because standard vector is a templated type, right? It's a type with a template that's like concrete type has yet to be defined. So when we just say standard vector, we're no longer referring to just a type like we are here. We're referring to a templated class that is templated across two classes. Now, if you're confused about the two classes thing, that's pretty easy. If we go look at standard vector, you'll see any standard vector is actually templated across two classes. It's written up here, right? So our vectors expect a class T, which is the type they contain in the container, and they expect a allocator, which is how to insert stuff. I don't know much about the allocator. You're probably like me. You've probably never played around with it. Because it's a default, right? It's a default template parameter. So it's by default standard allocator T. So yeah, what we're saying here is like, this is essentially just describing like the vector's shape, right? It's like, it's a templated class that expects two classes as the template parameters. The syntax here is a bit weird, but it's what the compiler wants or likes. It used to be something else, but that didn't compile. So definitely get familiar with that. It's actually really simple once you get your head around it. We're just saying that cont is now a class that is templated across two classes. There's probably a couple other ways to do this, but that's the way we're showing. And then you see now, because I haven't been concrete, like see here I've got my concrete container type. That's why we just have cont, because that was the type that was resolved. Here though, cont is no longer a type, like a concrete type, it's just that standard vector templated type. So now I have to actually give it its like underlying types. Now cont T makes sense. If I just wrote this like this, you'd be like, oh yeah, sure, I get it. This time I'm just passing in a standard vector. So the container has to be standard vector of a particular type. That makes sense. The reason there's extra things here is because the compiler doesn't seem to like it. It gets annoyed because it's like, hey, this is a type with one type, but you said you're going to give me two, so you got to give it two. It's a very strange.
Did you say that was defaulted though?
I know. This is why the code didn't work.
Can you do class equals? Didn't allocate
Maybe.
Example with just a single like template type name on that template result, and without the allocator bar. And it didn't compile initially, but I think when I set the standard to C17, it did compile.
Oh, cool. That could be it too. Could be even easier. I will play around with that too. It's a good example to play around with on your own computer. I definitely recommend you do. Regardless of the details, I hope you get the concept that instead of giving another concrete type here, we're basically saying, here is another templated type. So just notice that type name cont is replaced with this funky thing cont. That's just to say it's a template.
It also works with set and unordered set, the old one.
It only works with certain ordered sets. Is that what you
Set
said?
and unordered set.
Certain unordered set?
No, and set and also unordered set.
You're saying set and unordered set works with this?
Yeah, the old one.
The old one?
Yeah.
Oh, yes. Yes, once you have to start getting specific with these classes, everything starts to fall to shit because sets and unordered sets have different amounts of stuff in here. Anyway, I'll go and there was a conversation about this with, again, me and Matt and Nathaniel weeks and weeks and weeks ago, and we solved it, and then I thought we updated the slides and we didn't, so we'll just have a quick chat again because it's obviously still coming up.
Is the standard allocator really necessary for address this problem? Can you just replace the templates class to template or type name and another type name?
Potentially. I tried a bunch of stuff out, and this was all that worked. I'm not saying no. I'm just saying I don't know at the moment, and I'll go have a look. Or feel free to play around yourself, please.
For this slide after template one.
Yep.
How do you actually call that function?
How do you actually call it?
Yeah.
Damn it.
I don't know if you showed me something.
Yeah, that's true. We can probably quickly try and do that. This is probably one where, yeah, of course we need a main. I don't know why we had this in. I'm not sure where it went. I'm so sorry.
have to change that into unsigned.
Yes, yeah, that was the hellish experience we had. It was something like this. I distinctively remember that. Sorry that there's like the occasional 10 or 20% of the code that just doesn't compile. I doubt that's the minimum. Oh, wait. I have to do C properly. Sorry, guys. Well, let's see if this isn't full of shit. Okay. Yeah, there was some issues with type compatibilities, which was interesting here. Why is that? Oh, okay. I'm just depressed. Heavens knows why. That's how you call it. We like this example because it's like an example of template argument deduction, right? Because we're not actually telling find min what type it's templated across. It's deducing it from the call type here.
Does that work for like containers as well? Or is that only for arrays? Just square bracket size?
It's definitely okay for functions. It's not to do with the square bracket size stuff. I mean, argument deduction can happen in tons of stuff.
Does it resolve size to, like, as it notes up the size of the, like, type?
Oh yeah, that's just a particular peculiarity towards C arrays.
Oh, so then you make it.
Yeah, that's just how it does for C arrays, not any real like classes or anything. Yep.
What happens if the array's empty?
Oh, guys. You know, people always ask me like, "What's it like teaching this course?" And I was like, "It's pretty much just 10 weeks of being asked questions you've never thought about before."
Like size 0, right?
Oh, piss off. Okay. Okay. So what do we got? No matching function call. Fascinating, isn't it? Did you expect that to happen? Were you trolling me, or?
No, I was just interested.
Oh. Cool. I don't know why do you think it's doing that, guys? It's like, why is int 0 so
Bug in the compiler.
bug in the compiler? I've never thought about int 0 before. There you go. Someone had a question?
What's the difference between this and just running another template function that we used to do, like really week 2 or 3 or something like that?
Well, what do you mean exactly?
Like initially, when the very first example with min function, we just created more function and we turned it to a template, and it seems to do exactly the same thing. So I'm a bit, what's the whole point of this?
I mean, compared to the first min functions, this one has multiples. The example we went through in lectures was sorry guys, sorry my brain just turned off. Was something more like this. Where we like just, didn't use that extra fancy non-type. But yeah, like the normal min we did was to find the minimum of 2 items.
Yeah. Surely you could have written it the same way for an arbitrary size as well, right?
The min function?
Yeah.
I mean, that one was just the old, A is less than B, return A else B.
But there's nothing to stop us still maintaining within that, just making a loop for an array. Yeah, sure, you pass the size, but you still get the same result.
Yeah, for sure. We could just expand on that same min function.
So I'm just saying, well, what makes this different from doing it that way?
Well, I mean, maybe I'm misunderstanding you. If I am, I
Maybe
apologize.
it's an idiot, but that's the question that came to my head.
Yeah, I guess it's just because this one was actually just like it just took in 2 parameters. Like we could modify it completely to take in multiple parameters, but then now we've just got the function above anyway.
So there's no difference.
Yeah, that's okay. I'm not sure if I'm.
To me, I just don't see the difference in why we got perfectly special syntax for this when we could have still written an old school way.
I mean, we don't have to. I mean, the other things are. Where's my mouse gone? So I don't know why. I think this isn't a. Does anyone else run Linux on their machine? Okay, I'm all alone. Occasionally things stop working. Like now my mouse doesn't work anymore. I don't know why. It usually it comes back after like 20 minutes. Yeah. I guess they're just different functions because this one's taking in an array and the other one's taking in explicit parameters. Yes.
Sorry, 2 questions. They might be quite silly questions. I apologise. Can you just scroll to the top, please?
Of this.
Yeah.
Yep.
Is there a particular difference between the ampersand A being in brackets and not?
I don't know. I mean, it's all going to be order of operation stuff. Probably because I assume this could be quite ambiguous to the compiler. We can try it out though. Should be the motto of the course. Try it out. My mouse. Declaration of A is array of references. Oh, right, sure. That makes sense. Yeah, it's getting real confused now. It thinks you're asking for this.
Okay.
And it's just like, what? Yeah, because now it's like, an array of type T references as opposed to just the address of arrays of type T. Yep.
There's another question as well. Something that's always confused me a little bit. If you've got a function and you're passing parameters into it, what is the inherent difference between, say, or the benefit of, say, passing in a reference instead of passing a pointer, say, doing like some like int star as opposed to int ampersand?
Yeah. So. The main, references are essentially pointers with less control.
Okay.
I guess there's two big things about references as far as I can see. The first one is that references have like less syntactic sugar you need to make them happen, right? So when you have an object like an int and you want to pass it into a function, you have to pass the address, and then the function has to take in pointers to something like this. You got lots of pointers and whatnot floating around. When you set a variable as a reference, what happens is like you can kind of code normally like it's a value. So syntactically, it's a lot cleaner. The other reason is that I guess the way I'd describe it is like references have, like there's less you can do with them. In particular, one is they can't be null, and two is they can't be re-pointed or re-referenced somewhere else. And by making them less powerful, we reduce our surface area for basically fucking them up. So again, like the example we give is you go back to first year computing and 50% of the errors students make are that they have null pointers are floating around their code. So when we remove that ability to create a null pointer, suddenly we remove a whole set of source of bugs. And same with the repointed thing, you know, it's like once a reference is set, it's always referencing it that. So pointers essentially, we use them besides for like heap memory stuff, whenever we need to violate these two things, right? Like whenever we really need something to be null or whether we really need to like rechange where it references, then we use pointers, I'd say. Cool. How's everyone feeling? Who's got another exam that isn't C++? Oh, that's sad. Yep.
The static cast called the constructor. Like
the static cast call.
the constructor.
What are you asking there? Sorry.
So I think let me just find. So the stood forward is like equivalent to static cast t ref ref. Right. Like.
Oh, this is all that stuff.
It's like the most interesting thing.
Are you just looking at the? Are you looking at the reference or something else?
It's like Stack Overflow. Like it's just like that's what forward returns, right? Like it's all like it just passes it to like this that'll result in either an R value reference or an L value reference.
Yeah, it's one of those things that I understand. I've never thought about standard forward in the context of its return value. Again, let me go and do some digging about that, and I'll get back to you.
It's like the stack post said that it's like if you just do static cast t, like you don't have the ref, it'll still return like the correct type, but you'll have like an extra copy. And
I mean, I guess that would make sense because.
so does that mean static cast?
Well, I mean, it's going to call the move constructor, right? If it's going to call a constructor. Yeah, exactly. I mean, standard forward's job's not to copy; it's just to forward the type of something.
Wait, but does static cast involve like a constructor at all, or like if you want to cast one type to another, do you have to call the constructor like you define like for type conversions, you define a constructor with that type, right?
Yeah, I don't think static cast calls a. I don't know. We only really deal with primitive static cast in this course, so I haven't given a lot of thought to some of the more complex ones. Let me again add that to my list. Yep.
Just a couple of questions. Unique pointers. If you STD move them or something like that, what happens to the underlying objects? Will just get destroyed?
If you standard move a unique pointer, the resource that it's owning will just stay as it is.
Okay.
Nothing bad happens.
Okay. So, and is it only, if you use SD move, is it only send a template items that get sort of resources wiped out?
What do you mean, sorry?
You know, if you took an STD move,
Yep.
you know, you take a vector and move it from somewhere else, does the old vector just get destroyed completely? Or, and is it only STD items that do it?
It would all depend on how their move constructors are written.
Okay.
And I'm not too sure. I assume in the case, I mean, it depends. Like, I don't know a lot about the implementation of standard vector. Maybe it uses a whole bunch of heap items underneath. You know, like maybe it's just doing tons of mallocs and has a whole bunch of unique pointers or something. So when you're standard moving it, you're just moving. I'm not sure. It would be dependent on the implementation, to which I just described as probably not the implementation.
Alright, thanks.
It's okay.
Do you put override in your destructors?
Sorry, Matt's polymorphism is the one topic I'm least well across. In what context? Like, you mean like when you're trying to override a virtual destructor?
Yeah.
I can't see why you wouldn't. I mean, if you're overriding a virtual any type of function, but I'm not sure if there's a special case for destructors. I don't know about it, but I'll ask. They could very easily be
Like online will be destructors written without one.
Yeah.
Even for overrides.
Just mark as virtual, and then all the derived classes as well.
Okay, yeah, I'll check on that. Yep.
I guess this is just for Thursday. Like, now that you know most of the questions that are going to be there, how would you say that we should tackle the exam?
Tackle the exam. You mean like?
How would you, like, what strategy would you use to, like, which part would you once we're in the second tower? Like, is it better to go to short answer or like pure practical?
I would look through the questions, and the questions that I think I know the answer to, I leave them alone and come back to them later. And then I go to the questions that I don't know the answers to, and I think about it so I understand what I'm confused about. I'd maybe start it, have an attempt at it, then like just keep jostling between stuff. Just because it's the kind of exam where, you know, it's not like a high school maths exam where it's essentially a, you know, Formula One match where everyone's just got pens instead of cars, you know, and everyone's just like blitzing it out. It's like you probably have to think about some stuff, and there'll be a question where they'll be like, you know, do some overrides, and you'll be like, oh shit, I forget about that. But then like look at that first and think about it, just because like you always want that time to have it in your mind. So I definitely just start with the harder ones first, not the ones you just like completely don't know. Like if you see a question and you're like, shit, I'm all out of luck on that one, just you know, leave that one. It's probably not going to be worth your time. Yeah, harder ones first. Do you want some more detail? Was that too vague?
Yeah.
I'm not really sure. How can I help you?
Guess, like, is it like, what's like I know it's probably too much detail, I guess, in that way, but it's the distribution of, I guess, like harder to easier, more straightforward questions.
In all three sections, we try and go easy to hard through it. So we have like easy multiple choice to hard multiple choice, and easy short answer to hard short answer, and then easy coding to hard coding. It's not so. That's a great question. It's not so much that the exam's like easy multiple choice and then all the coding's really hard. There's some hard multiple choice questions, and there's some easy coding questions too. And some of the coding questions will be like tutored questions as well. Yeah.
So for the first specialization, why don't we consider the inheritance? So that we can save a lot amount of the
What are you referring to here?
the partial specialization in this part is
What is this on? What slides is this on?
it's advanced template.
Sorry.
Advanced template.
Oh, templates.
Yeah.
Advanced templates. Yeah. Cool.
So page
Sorry.
page
3.5?
Yeah, for partial specialization, why don't we use the inheritance? So that we can save a lot of money.
I get what you're saying. I guess you could. I'm just trying to think if there's a problem with that, or if we just did it this way because we hadn't talked about inheritance yet. I do think there are a lot of partial specialization situations you could use inheritance for sure. The only problem is like your inherited class would have to have the same type, I believe. Unless you did something funky with templates.
So which one is faster?
Which one is faster?
Yes,
You mean like at compile time or at run time?
not compile time.
I don't know about compile time. I mean, I'd maybe guess the polymorphic one because there's less code to generate. At runtime, probably the template one because that's why we use templates because there's nothing dynamic happening at runtime. There's no like creation of a class and then I've created it, so I have to go and create my base class and different stages and stuff. Nothing is asked as in the exam, just in case anyone's worried. Yep.
Just a specific question about the exam with regards to testing. Like, just using a straight diff between the output of your file with what you expect. Now, there's no auto test. Like, what about things like white spaces and like return carriages?
That's a good question. So when we auto mark, at this point, what it looks like for a lot of the questions is that most of them will be auto marked, where we'll pretty much diff the output after we trim off any trailing white space. And
Also, you do trim.
yep. And then for many of the questions, we will also do a visual sanity check. So, but that sanity check will not be to award you marks, just to be clear. That sanity check will only be to take marks off you. It's an example like if we ask you a question like, hey, can you write the type trait is pointer, and you just do it by like hard coding in some values or something, and then you pass all the tests, like when we're flicking through your responses, we'll see that very clearly, and then we'll just adjust your mark manually. So yeah, the manual marking is mainly just to make sure you don't just like botch the question. And again, just to anyone, don't botch questions just because you think you'll get the marks, because you will not. But also anyone who's here, I wouldn't worry too much about the exam either. If anyone here is thinking about failing, I don't think you have anything to worry about. I've seen pretty much everyone here in the lectures for a lot of the course, so.
Goldfish.
Yeah, there's a couple of random faces. You're screwed.
Goldfish memory.
Goldfish memory. That's okay, you won't remember the pain for very long then at least. Yeah.
On the off chance that we absolutely bugger it up, something silly,
The exam.
how quickly will we know if we got a sup or not?
How quickly will you know if you get a sup? So, as of T2 2019, UNSW has completely removed the notion of what they call sympathy sups. So we weren't meant to give them in T1, but many CSE courses did because we were still adjusting. So the only case for sitting a supplementary exam in this course is to not sit the exam due to illness or unforeseen circumstances and apply through special consideration within 3 days of the exam.
Special situation.
Special consideration.
No, you said in case of illness or special situation.
Yeah, like
Your train died and you couldn't get the exam.
Yeah, the train died.
1.5 hours. What is that?
Yeah, stuff like that. I mean, the special consideration team deal with all of that. So, like the train delays we had last, whatever day, there was the bad ones. There was an exam that day. I assume some students applied for a special consideration. I assume they probably got it, but I don't know. That's all up to the team. Yeah. Yep.
This is just a random question, but if too many people fail the hurdle, do some people get scaled up?
That's a good question. Yes is the short answer.
Okay, cool.
So my understanding of university policy is that we don't scale down. We're not meant to scale down. So and this is just for everyone who cares, it's in our interest to make this exam hard because we can always scale you up. So whether the exam's easy or hard, you're still going to get roughly the same mark, right? Give or take the particular types of questions there were. If it's too easy, we run into problems where we can get like pass rates of 95%, which is like way too high. So typically a fourth year course will have a fail rate of around 15%, which like sounds high. I know everyone bring this up, but it's not that high. It's quite low. First year courses have fail rates of like 22%. It's dramatically high. But again, all the people that will fail the course tend to not even be listening to this video a lot of the time. So most people fail because of negligence, not because of incompetence. Yes.
Just interesting you said that actually. There's a university in the UK, Imperial College, and their first year fail rate's like 45% or something like that.
45?
Yeah, something like that.
Yeah, it's. I heard the uni tries to keep fail rates higher in early years and lower in latter ones because they're trying to like really push people out of areas they're not meant to be. Like if this isn't the degree for you, they want to figure that out early rather than later, so that the attrition happens early. But that's interesting that it's so high. Anything I've said about
it does get itself rather Oxfordshire, so
yeah, it does. Anything I've said about university policy and all of that, that's just conjecture. I don't even know where to look that up. It's just what people tell me. But yeah, so in terms of the hurdle, yeah, it's likely to sit around the mark unless something awful happens. Is the person texting me the one that asked? What's your name? I'm texting anyone, not me.
William.
William. Okay, thank you, William. Sorry. Yeah, it's not impossible that we would scale up the marks prior to doing the hurdle cutoff. But it's unlikely. The exam is like designed that way, so that it should be all okay. I know again, if anyone thinks like that 30 to 35% sounds, does anyone think that's a high hurdle?
Yeah.
It'll be okay. Like
there's Murphy's law, the bounds of where you
yeah. I mean, 35% in multiple choice is what, 8 or something? 7? 7 out of 20. It's like should be okay. The only thing I'll tell you is that we will make sure that everything is fair. Because our aim too is to go to sleep at night being like we fairly assess students. So if you're a competent student, then the system will work. That's my intention for it. You know, and yes, in some crazy case where 70% of the students don't get 35% in part 1, then yes, we would adjust the marks and stuff, for sure. We'd make sure it's all good. Yeah.
Will you release some programming questions?
Yes, definitely. Hopefully tonight. Sorting out this last part of the exam and the environments and the auto marking as well as the final assignments are killing me a bit at the moment, but going to try and make sure they're out no later than tomorrow night. I know putting them out on Wednesday night is kind of useless, so that's why tomorrow night's like my last deadline for it. But it's also the thing with programming questions too is like a lot of them are just going to be like tute-like questions. So it's probably the easiest section to prepare for, to be honest, because the tutes reflect part 3 more than any other part, because there's just so much like we're going to write this code or we're going to modify this code or stuff like that. The reason I want to give you some practice ones is so you can, I guess, see the nature and how we're going to ask it. Cool. Last question.
Is there any way to debug in the exam? You know, like if you've written the code and there's an error and you're not quite sure what it is. I mean, is there any way to say step through code, or do you just have to use GDB or something like that?
Yeah, GDB is really what you'd want to use. I can't imagine. I mean, that's if you know how to use it. I understand most of the course don't know how to use it or have forgotten. But in general, the questions we're asking should in large part not require that kind of debugging. Yeah, a lot of them, you know how like with template parameters, you know when you like compile, like you do this with the graph assignment, it's like I would imagine in this exam, you're going to have a bigger issue with your code not compiling than running incorrectly. Because just like your graph assignment, does anyone have memories of the graph assignment where they were just trying to get certain types or unique pointers or something to work together, and you didn't have a freaking allocator or ordering thing for the set working, and it was all just like collapsing? So it's going to probably be more like that then.
So do you get marks if like your code doesn't exactly work, but you've definitely shown you've got a crap load there trying to sort it out?
No, not really.
Not really, so it has to work.
Yeah.
Alright.
But again, it's not like in this 25 mark section we have like a 7 mark question and then we're just like, this has to work for 7 marks. It's a lot of like smaller parts. It's like, here's a 2 mark question, here's a 3 mark question, here's an 8 mark question with 3 separate functions that we're going to test. So it is all or nothing in a sense, but we're talking about like all or nothing for a couple or 2 or 3 marks in an atomic fashion. So yeah, you will see, by the way, you will see big questions that are like, this is worth 7 marks, but it's like the way we write them and the way we test them will be such that it'll be segmented. Cool. Yeah, good luck on Thursday. Who has a morning exam? Who has an afternoon exam? Okay. I'll be up on level 3 of J17 if you want to chat that morning. If you have any stresses, just shoot me an email on Wednesday night and we can chat and all of that. Otherwise, good luck.